the WOC students. Welcome back to one more session of your WOC, that is nothing but term 1 MCQs. So as I promised, today I'm going to send you the MCQs on alcohols, phenols and ethers chapter, students. So basically this is a top 50 most expected MCQs on alcohols. So already for term 1, as the CBSE has introduced the sample paper, I have already sent MCQs on solutions chapter. I have sent MCQs on haloalkanes and haloarenes. Okay, haloalkanes and haloarenes. I've already sent MCQs based on biomolecules. All right. I have sent MCQs based on this one solid state chapter. All right. I have sent MCQs based on P block. All right. Now I'm left only with the last chapter, that is alcohols, phenols, and ethers. More and more videos are going to come up, students. I'm going to start with the revision series where you will get your concepts more and more perfect. So join me for the revision series, which is coming up very soon. WOC always believes in free education, students. So World of Chemistry always believes in free and quality education. Remember, so whatever time I get, I'm going to spend it for you all. So please, your support is required. Watch the video. I'm going to do 50 MCQs and detailed explanation of each and every question. Detailed explanation I'll be doing for every question. Let's start off. So please go to the playlist. I have done all the MCQs and note it in your book. All right. So welcome again to all my WOC students. My heart, basically WOC is my heart. All right. So let us start off with the first question. Read the question, answer it, know the reason, mark the correct option. First question is this. Which of the following has low solubility in water? Wow. So when somebody asks me solubility, remember the hint or remember the clue what you should remember. So solubility always is something which depends upon the bulkier group. So remember, students, solubility decreases when alkyl group or the number of alkyl group increases, or solubility decreases when hydrocarbon chain increases. When hydrocarbon chain increases, that means hydrocarbon chain is nothing but the alkyl group, isn't it? Now you only check here two alkyl groups are there, here three alkyl groups are there, here only one, rather CH3 CH2, here only one. So सबसे ज़्यादा the maximum alkyl groups are this, so this will be less soluble. Easy. So remember this hint for this. I'll be giving hint for everything. So as the hydrocarbon chain increases, your hydrophobic nature means water, fear of water, that is fear of water increases, correct? That's why it will not be soluble. Easy. Let us see the next question. Diethyl ether is heated with 1 mole of HI. The products formed are what? Oh, easy. So the question is given. What should I do? Let us take the option. Read carefully. Diethyl ether. So I'm going to take diethyl ether. Easy. Now what did I do? I have added 1 mole of HI. Okay, I added HI. What will happen, students? There is a cleavage of the bond. Both are similar. So what is going to happen? One hydrogen or the proton goes and adds to this alkyl group and iodine goes and adds to this. What do I get? I get two types of compounds because this is a symmetrical ether, isn't it? Symmetrical ether, there's no criteria, no problem for me. So you can write the products. One is alcohol, ethanol, and one is ethyl iodide. Easy. So which option is right? This. So they said 1 mole of this the product formed ethyl iodide only, ethanol only. You only tell me, students. You only tell me. So both they said HI. So what is forming? Ethyl alcohol and ethyl iodide. Easy. Well, next question. In the following, they have given list of big, this one. So they said the order of acidity. So whenever acidity question is given to you, remember the hint, students. Acidity always increases when electron withdrawing group increases. Simple. Electron withdrawing group are what? Nitro group. First thing. So acidity decreases when electron releasing group increases. So electron releasing groups are all plus I groups, just like your alkyl group. Electron withdrawing group are minus I groups, just like your nitro. सबसे ज़्यादा, check this, nitro in this, where is nitro? Here. And in this, nitro is at this position, nitro is at the para position also. Always remember, careful, if it is at the para position, yes, this para to your functional group, this will be more acidic, right? So what will happen? It will try to pull the electron density and your proton is released. But in this case, it keeps on releasing the electron density and the proton release will become difficult in this case. So सबसे ज़्यादा it is in the para position. So option basically observe, सबसे ज़्यादा 4, then comes 3, then comes 1, then comes 2. Because 2 has electron releasing group, less acidic. 4 has electron withdrawing group, more acidic. Easy, students, easy question. Next one. In the following sequence of reactions, what should I predict? Predict compound D. Easy. पहले क्या करना? What should I do? I'm going to take ethanol. Okay. I'm going to treat it with phosphorus plus iodine. So in the exam paper, if you see phosphorus plus iodine, if you see PBr3, if you see Pi3, it's nothing. It is a replacement of the OH group by the iodine. क्या आएगा? CH3, CH2I. This is your compound A. Now, what did we do? We have treated this compound A with magnesium. Okay. Magnesium and ether. Always remember, it is a Grignard's reagent which will undergo addition reaction. Correct? Addition reaction. Write this compound, add everything. It's going to go CH3. That's all. This is compound B. Now, to this compound B, you added formaldehyde. Let us take that Grignard's reagent is here. No problem. Formaldehyde. So H, C, double bond O, hydrogen. Easy, students. See here. Oxygen is electronegative. It will drag the electron density, right? When it drags the electron density, this will become negative. This becomes positive. Easy. So observe carefully. When you cleave this bond, the magnesium atom is positive, alkyl group is negative. Now see, negative goes and adds to the magnesium atom and the CH2 goes and adds to the alkyl group. What will you get? You're going to get CH3, CH2, CH2 and OMgI. This is compound C. That compound C, we are doing hydrolysis. So let me take that compound C and let me do hydrolysis of this. So O. What will you do? You're going to break the bond. Exactly here. Positive sign goes to oxygen atom and the negative goes to magnesium iodide. क्या आएगा? You're going to get CH2, CH2, that is nothing but propanol and MgOH is out. So D compound is nothing but propanol. So where is the answer? Propanol answer. It is N-propyl alcohol. So reaction 1, reaction 2, reaction 3, reaction. Easy? Easy. Right. Let us see the next question. When phenol is treated with chloroform and sodium hydroxide, the product form. Wow, such a easy reaction, students. Always remember the reaction where phenol is treated with point number 1, chloroform, which forms a intermediate dichlorocarbene. Remember that. And sodium hydroxide is always salicylaldehyde. Salicylaldehyde. What is the name reaction, students? This is nothing but Riemann-Tiemann reaction. Correct? Riemann-Tiemann reaction. So phenol gets converted to salicylaldehyde with Riemann-Tiemann reaction. So option 2. So if you check chloroform, write that. Next one. Which of the following statement is not true about ortho, para and metanitrophenol? Okay, remember, boiling point of orthonitrophenol is lower than para. Correct. It's correct because of the hydrogen bonding. Now, nitration of phenol with nitrating mixture gives para-nitrophenol as a major product. Okay, so remember, basically, nitration of phenol with nitrating mixture, it gives para. That's also right, major product only, right? But they have given me, okay, let us read the third option. Para-nitrophenol is stronger acid than orthonitrophenol. Okay, this is a little bit doubt. Meta-nitrophenol is the weakest acid among them. Okay, so here the problem is with your acidic strength. Let us check. Acidic strength order, always remember students. I showed just now. Para-nitrophenol is more acidic than orthonitrophenol. This is more acidic than meta-nitrophenol. Always remember this order, right? So, what did they give me? This is one option. Let's take. Now, here orthonitrophenol, there is intramolecular hydrogen bonding, correct? So this is also, that's fine, but the nitration of phenol produces orthonitrophenol is major product. That's due to hydrogen bonding. That is also related. So where is the problem in the question now? Where is the problem in the question? Para-nitrophenol is stronger as an acid. This is right. Metanitrophenol is stronger. This is right. Boiling point of orthonitrophenol is lower than paranitrophenol. Hmm. Yes. Is it right? Is it right? Please check. There is intramolecular hydrogen bonding in ortho. Yes. This is intramolecular hydrogen bonding. Yes, that's why this is also right. What is wrong, students? It is nitration of phenol with nitrating mixture gives para as a major product. So this is what is little bit wrong because meta also is there in that. That's the reason it is not true. Okay, so pick this option. Let's see the next one. Which of the following reactions can be used in the preparation of alkyl halide? All right. So they have given me a few options. Which one can I use it for preparation of alkyl halide? So remember students, check carefully. In the first case, yes, comfortably water molecule comes out and I can prepare CH3, CH2, Cl. Yes, alkyl halide I can prepare. In the second case also I can take first. So second case also I can remove water, not a problem. Third case, if I see tertiary alcohol, okay, remember students, this is basically a Lucas reagent. It is a Lucas reagent, correct? Now for Lucas reagent, which one is the order? Yes, so tertiary very fast, then secondary, then primary. So tertiary, immediately there is no requirement of catalyst, no catalyst or no reagent required. Immediately it will give turbidity, no reagent required. Correct? Okay, so this is possible. Where is tertiary present? 3. Okay, this is possible 3. Now observe carefully. Primary and secondary, they react with HCl. Compulsory, they require anhydrous ZnCl2. They require anhydrous because they're a little bit slow in the reaction. Anhydrous ZnCl2, they require it. Right. Now compare which option is can be used. Yes. Let us see option D. In the first case, anhydrous ZnCl2 is there. Yes, I can take that. Third option, tertiary is there. I can go with that. Fourth option, anhydrous ZnCl2 is there for secondary. Both require so this. So the perfect option is 1, 3 and 4. because according to this order, I require. Next one, students. The reaction between, so there is an alkoxide. So this is tertiary alkoxide and primary alkyl halide. Correct. So the reaction between tertiary alkoxide and primary alkyl halide is always, or formation resulting in the formation of ether is nothing but Williamson synthesis. Easy, students. It's the best method to prepare your ethers. Next option. Consider the following reaction, that is phenol in the presence of zinc dust is giving X. So alkyl halide or further alkylation gives Y. That Y you are treating with alkaline KMnO4, it gives Z. What is the product? Let's see. So phenol is there. I'm going to treat it with zinc dust. So it's nothing but reduction is going to happen. So reduction, that is removal of oxygen or addition of hydrogen. Phenol gets converted to benzene. Done. Then further what did I do? I did alkylation. That's nothing but Friedel-Crafts alkylation reaction. This also is done. So what is going to happen, students? Alkylation. This is an electrophile. It goes and attacks the benzene ring. I get toluene. Sorry for the diagram. I get toluene. Okay. This is your X. This is your Y. Now let's take that toluene and I'm going to treat it with alkaline KMnO4. Okay. What is alkaline KMnO4 doing, students? It's an oxidizing agent, correct? Irrespective of the size of the alkyl group, they get converted or they get oxidized to acid. So you get benzoic acid, right, students? Benzoic acid. So which is option? That. Next question. Propene can be converted to propanol by oxidation. Indicate which set of reagents among the following is ideal for the above. Easy, students. Remember, hint is whenever alkene is given to you, and that too unsymmetrical alkene. If somebody says getting converted to primary alcohol, alkene to primary alcohol is always which one? It is nothing but hydroboration oxidation reaction. So this is hydroboration oxidation reaction. So that hydroboration oxidation reaction always uses diborane alkaline hydrogen peroxide. Right. So immediately alkene, step by step rather, it first forms tripropyl borane, then forms primary alcohol. So this is nothing but option C. Done. Next question. The major products C and D formed in the following reactions are. Okay. So here they have given me one ether where you have a tertiary group, alkyl group. So what is the hint, students? Always remember, whenever you have a primary alkyl group and you have a tertiary alkyl group like this, when you're adding excess HI, remember, which is the strongest acid, right? Right. The negative part or the iodine, which is a better leaving group, where will it go? It will go and attack the stable compound. Which is stable? Tertiary carbocation is more stable. So the negative or the nucleophile goes and adds to the tertiary carbocation since tertiary carbocation is stable. So that tertiary carbocation will go. What product I get? I'm going to get this CH2COH ethanol, propanol, and I'll be getting a tertiary alkyl halide. Tertiary alkyl halide. I. So what is the compound? So it's option A. Okay. So no, option A is right. Did we write it wrong? So ethers readily attack. So what is this option, student? Okay. I got one ethanol and I saw not this option. Let us mark option B because ethanol and tertiary iodide is what I get. Easy, easy students. But here one excess HI they said. So normal HI means I get this. This is not excess. This is normal. Suppose if they say excess HI, should not go with this option, students. This is normal HI means a room temperature, because they said excess HI, you will be getting both products. So this is the correct option. Correct option if you see excess HI. So what to remember? ROR. ROR plus 2HI. You're heating it. You will be getting 2 alkyl iodides. Like this. Note it. Okay. Alright. Normal excess HI is that, and this one is this. Next page. Which of the following pairs of compounds are functional isomers of each? Yes, it is this. Why? Because alcohols and ethers are functional group isomers. Correct? That's why I've marked that option. Yes. Next question. Primary alcoholic group. We very well know this one because primary alcoholic group has two hydrogens, correct? One R group and one OH group. So this is primary. Next question. Ethyl alcohol containing 9.5% methanol and 0.5% pyridine is called. It's nothing but denatured spirit, students. So remember this question. It's a direct percentage where you can. Next question. Breaking of big organic molecules in the presence of enzymes. It's a natural fermentation where just like your you keep your batter overnight, it gets fermented with the enzymes. Fermentation. Next, when alcohol is most reactive towards HCl in the presence of Z anhydrous ZnCl2, which so once you see HCl and ZnCl2, remember it is nothing but Lucas reagent. Lucas reagent order is what? Tertiary more than secondary more than primary, because tertiary carbocation is more stable. Correct, no students? That's why you're going to take tertiary. Within seconds, you get the reaction or turbidity. Okay. Isopropyl alcohol on oxidation forms. Simple. Take isopropyl alcohol on oxidation. Do oxidation. So oxidation is removal of hydrogen, addition of oxygen. Either remove the oxygen, add oxygen or remove hydrogen. Remove both the hydrogens. What will I get? Ketones or acetone. Take this. Easy. Mark this option. Right. Next question. When tertiary butyl alcohol is passed over reduced copper, the reaction taking place. Easy. Tertiary butyl alcohol. Okay, I took tertiary butyl alcohol. I took copper, reduced copper. So what will it do? It is going to do, it will add hydrogen, hydrogenation concept. It is going to add hydrogen, means add hydrogen. Where will it add? Where will it add? So hydrogenation or dehydrogenation? Yes, wrong. Because it is a reducing agent. Yes, it will do dehydrogenation, not add. It's going to remove hydrogen. From where, students? It's going to remove from, see, basically, one second. What is the confusion? Wrong. Again, this is also because copper, when it is there, it's going to remove water. Yes, this is right. Let me erase this. One second, students. Let me erase this because this one was, it is going to remove what? Okay, right. Let's take. Okay, sorry for this. It's going to remove water molecule. right? So where will it remove water? OH from here, H from here. Dehydration. So the bond, whatever is here, is going to shift, and I'm going to get alkene. This is what happens. So on dehydration, reduced copper, the reaction taking place with tertiary is conversion of tertiary alcohol to alkene is dehydration. Easy? Okay, sorry for that. Next question. When ethyl alcohol reacts with bromine in the presence of red phosphorus, the compound formed is simple. Take ethyl alcohol. They said bromine in the presence of red phosphorus. No problem. See, if you see in the exam paper, red phosphorus, PBr3, like this, no problem. It's just going to substitute your OH group. So your bromine comes out and one more hydrogen comes out with bromine. So what is the compound, students? It is nothing but C2H5. Next question. Which of the following on oxidation gives ketone? Okay. So we very well know, remember, when somebody says oxidation process, remember, primary alcohols on oxidation gives me aldehydes, which on further oxidation gives acids. Secondary and tertiary alcohols on oxidation gives me ketones. So secondary alcohols on oxidation gives what? Yes, secondary and this one on oxidation gives ketone. Easy? All right. Right. So option done. Next, easy. Students. A compound A reacts with sodium metal to give B. Okay. A also reacts with PCl5 to give C. Done. B and C reacts with each other to give dimethyl ether. Then A, B, C are what? Easy. Let's write. A reacts with sodium metal to give B. Okay. Then B. Then A also reacts with PCl5 to give C. All right. Then they said A and B, B and C, both of them react. B and C, both of them react with each other to form dimethyl ether. Dimethyl ether. Okay, done. This is what they have given me. So find out A, B, C. What is A? What is B? What is C? Easy. Now see. A reacts with alkyl. Here, I don't know anything, but there is one clue which is given as a product, right? So, in this, both are symmetrical. So, one compound, you are going to take it as A. See here. CH3OH. This is A. You are reacting with Na. What will you get? You will get alkoxide, CH3ONA. This is B. Over. Now, A and B combine this set. So A also reacts with PCl5. Let us take that. CH3COH reacts with PCl5 to release what? POCl3 plus HCl and Cl forms methyl chloride. This is also done. Then they said A and B react. React OH plus NaOCH. What will I get, students? I'm going to get dimethyl ether. Easy. So I have written the reaction down. So compound A is methanol. Compound B is, compound C is, which option is right? So compound A, B, C. Chloride. So first one, shall I take ethyl chloride methanol? Yes, right. A option methanol. Third, right. That's perfect. That's clear, students. Easy. Done. Next option. Two organic compounds A and B react with sodium metal to release hydrogen gas. A and B react with each other to give ethyl acetate. Oh, nice. What did they say? A and B. They react with sodium metal and they are going to release hydrogen gas. A reacts with each other. A and B react with each other. Yes. And they are going to form which compound? Ethyl acetate, they said. They'll form this compound itself. Okay. What are A and B? Easy, students, see here. We very well know. The substance which releases hydrogen gas on reaction with sodium metal are either acids or alcohols. Correct? Acids or alcohols. That's one. Second thing, they have given me a clue here. One is C2H5 group, one is CH3 group. Correct? So I can take one A as C2H5, COOH. Right. Then I'm going to take B as C2H5OH. Done. So what will happen? Both will combine with sodium metal and finally they said it's going to give me ethyl acetate. So take out water molecule from here. Combine CH2H5. Yes. So I'll take this as CH3. This is better. Okay. C2H5 done. OOCH3. So this is acetate. Done. Simple. So what is the answer, students? Acetic acid is one. Acetic acid is one. Or you can take it as like this also, ethanol. So if you are, because the product here is not given to the concerned thing, we can make in the other way also. Let us take this reaction and make it in the other way and see, because the options are varying in this. So let's do. So the proton side of this is coming from the proton side, or the proton part is coming from your uh, alcohol. This is what they have taken there. So that's why I'm going to change the product and write. Just see, students, let me arrange my camera. Okay. So basically, A compound, ethyl acetate, I'll take it as this acid. Then B compound, I'll take it as alcohol. Right. So here, remove water molecule and I get or CH3COO C2H5. So that's the formula. Easy. So both of them react with sodium metal and they give hydrogen gas. Done. Next one. Which of the following reagents is useful in converting one butanol to one bromobutane? Okay. Whenever you want to convert butanol all to butane, one bromobutane, simple. Try to add PBr3, PCl3, PCl5, like that. So the option is this. Next one. Which of the following is a starting material for the Grignard synthesis of tertiary butanol? All right. So remember, when somebody asks you to prepare tertiary group, so first check which molecule is given. So tertiary, write the structure. I have to prepare this. All right. So already 4 carbons I require. So in this 4 carbons, please check. First one should be the Grignard's reagent with 1 carbon. The remaining is nothing but a ketone group. Now, when these two combine, oxygen pulls the electron density. There is a cleavage of the bond. This becomes your negative. This becomes your positive one. So positive comes and attacks oxygen. Negative comes and attacks this. So what do you get? You get a compound OMGBr and your CH3. Now simple. Do hydrolysis to this. The bond. Yes. So finally, you will get tertiary butanol. So what are the two compounds? One is acetone and one is methyl magnesium bromide. So option easy. Right. Next question, students. Ethanol, when treated with PCl5, gave A, POCl3 and HCl. A reacts with silver nitrate to form B as a major product and AgCl. A and B are what? Easy. Take ethanol, it reacts with PCl5 and it gives A. Okay. Plus POCl3 plus HCl. What is it? In the presence of phosphorus chlorides, you'll convert ethanol to ethyl chloride. Done. Right. Next. A reacts with silver nitrate. A reacts with silver nitrate. Silver nitrate is a covalent compound, correct me students? It's a covalent compound. So when it is covalent compound, what will it do? It will act, or the nitro group will add as an ambidentate ligand. Ambidentate ligand. So what will happen? So C2H5ONO plus AgCl is what comes out. This is B. Correct? So check the option. Option right. The order of reactivity of alcohols towards sodium metal or potassium metal is, always remember, sodium and potassium are active metals. For active metals, the order of reactivity of alcohols is tertiary, always remember, less than, secondary, less than. So which option? Indirectly, if I say primary is more than secondary, more than tertiary. So option 1 is right. Next, the order of reactivity of dehydration of alcohols. Okay, so always whenever we have dehydration happening in the reaction, check tertiary undergoes dehydration faster because tertiary carbocation forms, yes, alkene. So what is the order, students? Always tertiary first, secondary, then primary in the presence of a dehydrating agent, concentrated sulfuric acid. So dehydration, tertiary is always preferred because it gets converted to alkene. So which option is right? See here. Indirectly, or can I write it as 1 degree, less than 2, less than 3? Yes. So this option is right. Next. The dehydration of butanol gives what? Easy. Take butanol. Okay. 1, 2, 3, 4, all. So they said butan 1 all dehydration. Okay. So I'm going to add concentrated sulfuric acid. So which is the major product? They said. So we have, now students, you can remove OH from here, hydrogen from here. Yes. You can remove OH from here, hydrogen from here. Two types of products. One primary and secondary. So here they said dehydration, they said. So here, let's see, I can get two types of products. One way, this. So the highly substituted product, that is nothing but butene or butene or butene or butene to butene is always a major product. 80% is this one. But1ene is always minor, 20%. So 2-butene is a main product. Yes, remember that. Clear, students? Okay. Now next question. In esterification reaction, the correct order of alcohols. Okay. Always remember, esterification reaction, you're always going to take, remember, hydrogen atoms from alcohols. in esterification reaction, always you take hydrogen atoms from alcohols. Okay. And you take OH atoms from acid. Remember that. So ROH plus RCOOH, hydrogen from alcohol, OH from acid, it will form ester. And the order always, remember students, primary greater than secondary greater than tertiary for esterification. Whenever you have alkyl groups more, they will increase electron density on oxygen. So polarity decreases. Correct, my students? The polarity decreases automatically. More alkyl groups are there, polarity keeps on decreasing and acidic strength also decreases. So esterification, always remember this order. So basically, yes, what is the order, students? Primary, more than secondary, or methanol, first then secondary, then tertiary. Is it okay? So which option is first? So this is methanol, primary, second. Clear? Okay. Methyl pentanol is what? 2-methyl pentanol. Okay. Let us write structure. Okay. This is 2-methyl pentanol. What is its rules? Here you have two hydrogen atoms adjacent to OH group. So isn't it a primary alcohol? Just to confuse you all, they have given you this. So isn't it primary? So once the structure is given to you, try to write the structure and put it. Next. Primary alcohols cannot be prepared by the reduction of. Okay, remember always. Remember, when I have to take a carbonyl group, you will do reduction by addition of hydrogen. कहाँ यहाँ add करेगा? It will go and add here carbon, one hydrogen here, one hydrogen here. So aldehyde group, if you are doing reduction, the bond shifts carbon, alkyl, hydrogen, OH and H. Aldehydes on reduction gives primary alcohols. Ketones देखें. Let us see ketones. Ketones on reduction, same. Carbon, one alkyl, one more alkyl group, and one OH and H. Ketones on reduction give secondary alcohols. So, primary alcohols cannot be prepared by which method? Ketones. Because for getting ketones or to get primary alcohols, I can use or I have to use aldehydes. Correct? Yes, I can't prepare from ketones. Next, the two enzymes present in the yeast that are responsible for the formation of ethyl alcohol, invertase and dietase. Next question. An organic compound A containing carbon and hydrogen and oxygen. Three are there it seems. Okay. And has a pleasant odor with boiling point 78 degrees. Oh, I got the clue. Right. On boiling, A with concentrated sulfuric acid, a colorless gas is released. What is the organic liquid? Remember, students, there is a compound with carbon, hydrogen, and oxygen, and 78 degrees boiling point. And one more thing, when you boil this A with sulfuric acid, it gives a colorless gas. Simple, students. C2CH3 CH2OH. This is ethanol, has a boiling point of 78 degrees. First is the put point. Next, sulfuric acid is dehydrating agent. Concentrated sulfuric acid is dehydrating agent. It's going to remove water from where? OH from here and H from here. What will happen? Hydrogen lost, OH lost. You will be getting CH2. This is nothing but ethene. Yes, ethene is a colorless gas. It's a colorless gas. Remember this. So this is compound X, right? So the organic liquid which gives or which has a boiling point of 78 degrees is ethanol. You see? Okay, next question. When equal weights of methanol and ethanol or ethyl alcohol react with excess of sodium metal, the volume of hydrogen liberated is more in which? Oh, nice question. Let's see. Ethanol is combining with sodium metal and it's forming ethoxide plus hydrogen gas. So two hydrogens, I'll put two. Okay. Now let's take methanol. It's also reacting with sodium. It's forming sodium methoxide plus hydrogen gas. Here also I'll put 2. Here also 2. Here also 2. Now, see here. 2 moles of ethanol are giving how much? 2 moles of ethanol are giving 1 mole of hydrogen. Correct, student? Okay. Here also 2 moles of methanol are giving 1 mole of hydrogen. No change. Now, observe carefully. Suppose if I take methanol and ethanol, the number of moles if I take. Yes, for methanol, the number of moles are how much if I count x by 32. Let's take x of that. 32 is a molar mass. For ethanol, how much is the mass? X by 46. Now take the ratio. X by 32 is to x by 46. Which is more? X by 32 is more. Correct. So which one is having, which will release more hydrogen gas? Yes. Yes. Ethanol. So our methanol is going to release more hydrogen gas. So the ratio is X by 32. So this is more. So more hydrogen gas is released. Done. Next question. Which of the following gases liberated when ethyl alcohol is heated with methyl magnesium iodide? Easy. Take this ethyl alcohol. This is your ethyl alcohol. You're treating with methyl magnesium iodide. Okay, done. Iodide, done. Grignard's reagent. You're going to use dry ether here. What will happen, students? Simple. Careful. Whenever you're adding like this, OH from here and your basically the whole molecule. So you're taking that your CH3 from here. Remember. So not OH, sorry, this is H. Sorry. H from here and CH3 from here. I'm sorry, not this. So these two combine and form methane gas. Methane gas. What is left out, students? The left out is, yes, this is the compound. So what did they say? Which of the following gases is liberated? It's methane gas. So not this oxygen, proton with CH3. Next question. Which of the following alcohol is expected to have the lowest pKa value? Okay. So concept, remember, acidity question given means more electron withdrawing groups, more acidity, because it will drag the bond and proton is released. Yes. Now, when it is more electron withdrawing group, more acidity means Ka will be more and pKa will be less because K pKa is inversely related to Ka. That's it. So which one has more electron withdrawing group? Yes. Next question. ROH plus HX gives RX plus water. Hmm. The reactivity order towards hydrogen halides. So order of alcohols towards HX, hydrogen halides. Remember the order: tertiary greater than secondary greater than primary. Next one. They have given you a tertiary alcohol. It is undergoing mild oxidation. It's giving X. Secondary alcohol, it's undergoing mild oxidation. It's giving X. Further, you're treating with Grignard's reagent. It is giving Y. Now see, CH3, C, H, one more alkyl group. You're doing mild oxidation with nothing but potassium dichromate. Okay. So what will happen? Yes. So this is your isopropyl alcohol. Correct, Mr. Students? This is isopropyl alcohol. So oxidizing agent I said. So important. One hydrogen from here, one hydrogen from here is lost because oxidizing agent. And what is left? You will be getting a ketone, an acetone. So this is your X. Now X you are treating with Grignard's reagent CH3 MgBr and hydrolysis also. So when you do hydrolysis and you add that, you'll be getting a compound which is because oxygen is going to pull this cloud and OMGBr and you're going to get alkyl group and your CH. Further, you are going to do hydrolysis to this. What will happen, students? MgOHBr. It's basically like this. So MgOHBr is out along with your CH3, C, your OH and CH3 and CH3. It's nothing but your tertiary alcohol or 2-methyl propan-2-ol. So tertiary butyl alcohol is what you get. Take it. Easy? Okay. So isopropyl alcohol converting into ketones. So ketones on hydrolysis are giving you tertiary. Next question. Haloform reaction is not given by, okay, this compound. Why? For haloform reaction, what do you require? This group, methyl ketone, which is missing in this. Okay, next question. What is the final product obtained when chlorine reacts with ethyl alcohol in KOH? Remember, chlorine reacts with ethyl alcohol. First thing, careful. Alcohol, this is an oxidation process. Alcohols and oxidation gives aldehydes. Then this aldehyde, right, whatever you got aldehyde, it combines further with chlorine and again you're going to do KOH. A hydrolysis process happens. Chloroform. Chloroform is released with chlorine. Remember, note the reaction. Yes, students. So ethanol with KMNO4 X gives Y. Okay, very nice, easy. So I took ethanol. I treated it with KMNO4. Okay, it's an oxidizing agent. Hydrogen is lost, oxygen is added. I get an acid, which is X. Now, what am I doing? I'm trying to, so in the presence of sulfuric acid, there is Y itself, but they give an answer. I got a product CH3COO C2H5. Now, already in this you have acid compound. Already, see, acetate ion is there. So, what is left out, students? Acetic acid is already there. What is there? The left out is ethanol. Correct now. See here. Why? Because if I take ethanol like this, water molecule, hydrogen from alcohol and OH from this comes out as water because that's a dehydrating agent. So that's why Y is this. X is acetic acid. Y is ethanol. Yeah. Next one. ROH plus HX gives me RX plus water. What is this? I said no. Dehydration. The order of dehydration is always order of dehydration is always tertiary greater than secondary greater than primary. Okay, next. 3 moles of ethanol react with 1 mole of phosphorus tribromide to form 3 moles of bromethane and 1 mole of X. What is the following? Easy. 3 moles of ethanol are reacting with PBr3 to give PBr3 will substitute this OH and you're going to get plus H3PO3. Easy. So if you take 5 moles, you'll be getting POCl3 or POBr3 plus HCl. Okay, next one. Which of the following is most suitable for removing the traces of water from ethanol? Distilling with calcium oxide. Okay, then next, because it's a drying agent, no students. This is a drying agent. Remember this. Next one. Which of the following compound gives ethyl methyl ketone on oxidation? Okay, so I want ethyl methyl ketone. Okay, this is ethyl group. This is methyl. This is methyl. This is ethyl. What will I get? Oxidation. Remember. So butanol. Butanol on oxidation gives me alcohol. Correct? So 2-butanol on oxidation gives me ethyl methyl ketone. Why? Because see here, oxidation, addition of oxygen or removal of hydrogen. So 1, 2, 3, 4. 1, 2, 3, 4. I removed hydrogen from here. I added. So oxygen is there. I removed hydrogen. Oxidation. In CH3OH, the bond that undergoes heterolytic cleavage most readily in reaction with sodium. Right, let us take CH3OH. I'm linking with sodium metal. So what is going to happen, students? There is a cleavage of this bond. I'll be getting sodium ethoxide plus hydrogen gas. Correct? Yes. So what is this process called? Which bond is breaking? OH bond is breaking. Done. Next. What are X and Y in the reaction? Okay, what are X and Y in the reaction? Now, see students. C2H4. I'm combining with sulfuric acid. So can I write sulfuric acid as like this? H2SO, H2 SO, let me take SO3. Okay, SO3 plus 1, 4. Now what will happen? When you add, this hydrogen goes and adds to this. Further, this is X. You're doing water hydrolysis and you're heating it. What will happen? The bond breaks here, right? So here also the bond breaks. Proton goes and adds to this. And I'll be getting H2SO4. So I get ethanol. So this is the option. Next one. Which one of the following contains sp2OH bond? Easy. Vinyl alcohol. Why? Because vinyl alcohol is this. Where OH group is attached to a carbon directly attached. Means OH is directly attached to a C double bond C. All right. So this is how I've completed 50 questions. Students, top 50 questions are completed, and all are very, very important questions. Very, very important questions. So my request is please share. Please share. WOC requires your support, students. WOC always will provide free and quality education. So please share. Thank you so much. I'll be meeting you with the next series, revision series. Bye-bye.